Hello, everyone, and welcome to this webinar. I hope you're having a great day so far. My name is Anu Meha. I'm a technical product manager at AWS. This talk has technical content with demo and CLI commands towards the second half. If you're a business or a product manager, try to follow through as much as you can. You will be able to determine whether the ElastiCache online migration feature is applicable to your business use case or not. In this talk, you will learn how fully managed Amazon ElastiCache is highly available, scalable, and easy to manage. You will learn how the online migration tool will help you migrate your Redis clusters off of EC2 with ease, and get hands-on with the feature and learn how you can get started with an easy demo. Before we jump in, can you think of any workload that can benefit from speed? Whether it's a real-time system or batch process, you'd be hard-pressed to come up with a use case or need for a slow system. This is why we see a growing adoption of in-memory data stores. There are many popular key-value in-memory data stores, with Redis being the most popular, followed by MEMCACHED, Hazelcast, and others. Amazon ElastiCache offers fully managed Redis and MEMCACHED engines. You can seamlessly deploy, run, and scale these popular open-source compatible in-memory data stores. You can build data-intensive apps or improve the performance of your existing apps by utilizing these high throughput and low latency in-memory data stores. Amazon ElastiCache is a popular choice for gaming, ad tech, financial services, healthcare, and IoT apps. Let's talk some more about comparing MEMCACHED and Redis and how to choose between the two. As I mentioned earlier, both Redis and MEMCACHED are popular, open source in-memory data stores. Although they are both easy to use and offer high performance, there are important differences to consider when choosing an engine. MEMCACHED is designed for simplicity, while Redis offers a rich set of features that make it effective for a wide range of use cases. It is important to understand your requirements and what each engine offers in order to decide which solution better meets your needs. Let's first talk about the similarities in these engine offerings. Both Redis and MEMCACHED support sub-millisecond response times, which is much faster than reading data from disk-based databases. Both Redis and MEMCACHED are syntactically easy to use and require a minimal amount of code to integrate in your application. Both Redis and MEMCACHED allow you to distribute your data among multiple nodes, also called as shards in ElastiCache terminology. Sharding allows you to scale out to better handle more data when demand grows. Both Redis and MEMCACHED have many open source clients available for developers. These include Java, Python, PHP, C, C++, C#, JavaScript, Node.js, Ruby, and Go. Now let's look at their unique offerings. MEMCACHED supports key-value string data structure. In addition to strings, Redis supports lists, sets, sorted sets, hashes, bit arrays, and hyperlog logs. Your applications can use these more advanced data structures to support a variety of use cases. For example, you can use Redis sorted sets to easily implement a game leaderboard that keeps a list of players sorted by their rank. With Redis, you can keep your data on disk with a point-in-time snapshot, which can be used for archiving or recovery. Redis lets you create multiple replicas of a Redis primary. You can scale reads and have highly available clusters. Redis supports transactions, which let you execute a group of commands of an isolated and atomic operation. Redis supports pub/sub messaging with pattern matching, which you can use for high-performance chat rooms, real-time comment streams, social media feeds, and server intercommunication. Redis allows you to execute transactional Lua scripting. These scripts can help you boost performance and simplify your application. Redis also has purpose-built commands for working with real-time geospatial data at scale. You can perform operations like finding the distance between two elements, for example, people or places. Now we will deep dive into three aspects of this managed service offering with Redis engine: high availability, seamless scalability, and fully managed. Amazon ElastiCache for Redis provides high availability through support for automatic failure by detecting the primary node failure and promoting the replica to be the primary with minimal impact. Through replication, you can enable read availability especially when primary is busy with increased workload, including scale your reads by using a single reader endpoint to connect to ElastiCache read replicas. Reader endpoints keep up with cluster changes in real time as replicas are added or removed. Redis implements replication in two ways. First, with a single shard that contains all of cluster's data in each node. This is called Redis cluster mode disabled. Second, with data partition across shards up to 250 nodes in the cluster. This is called Redis cluster mode enabled. Each shard in a replication group has a single read or write primary node and up to 5 read-only replica nodes. You can create a cluster with higher number of shards and lower number of replicas, totaling up to 250 nodes per cluster. This cluster configuration can range from 250 shards, that is, 1 master and 0 replicas, to 41 shards, that is, 1 primary and 5 replicas in each shard. Like I mentioned earlier, multi-AZ automatic failover goes hand in hand with replication, which is achieved through at least 1 replica per primary in your cluster. If the cluster with replicas has multi-AZ with automatic failover enabled, and the primary node fails, the read replica with least replication lag takes over as the new primary for the cluster. This process usually takes just a few seconds until you can write to the cluster again and is much faster than provisioning a new primary node. This improves the fault tolerance of your architecture. Cluster mode enables requires multi-AZ with automatic failover by default and cannot be disabled. You can enable multi-AZ with automatic failover using ElastiCache console when you create a new Redis cluster or by modifying an existing Redis cluster with replication. Here's an example of a Redis cluster mode enabled configuration with multi-AZ enabled. It has 3 shards with nodes denoted by the Redis color icons. Blue color nodes are in shard 1, magenta icons are in shard 2, and orange are in shard 3. As you can see, each shard contains 1 primary, 2 replicas, and each node is in a separate AZ. Here is the first shard, primary located in availability zone A and replicas located in availability zone B and C. Here's the second shard, primary located in availability zone B and replicas located in availability zone A and C. And the third shard, primary located in availability zone C and replicas located in availability zones A and B. So let's look at what happens when only the primary node fails. If only the primary node in the shard or cluster fails, the read replica with the least replication lag is promoted to primary, and a replacement read replica is created and provisioned in the same availability zone as the failed primary. Here's how the process works. The failed primary node is taken offline. The read replica with the least replication lag is promoted to primary. Writes resume as soon as the promotion process is complete, which is typically just a few seconds. If your application is writing to the primary endpoint, there is no need to change the endpoint for writes, as ElastiCache propagates the DNS name of the promoted replica. A replacement read replica is launched and provisioned. The replacement read replica is launched in the availability zone that the failed primary node was in, so that the distribution of nodes is maintained. The replicas sync with the new primary node. What happens when majority of primary nodes fail, or when a primary with some replicas fail? Well, the recovery process follows the same as before. The primary fails over to the read replica with the least replication lag, and a replacement read replica is created and provisioned in the same availability zone as the failed primaries or replicas. Let's revisit the process. The failed primary node and failed read replicas are taken offline. The available replica with the least replication lag is promoted to primary node. Writes resume as soon as the process of promotion is complete, which is typically just 15 to 30 seconds. Again, no need to change the endpoint because ElastiCache propagates the DNS name of the promoted replica. Replacement replicas are created and provisioned. The replacement nodes are created in the availability zones of the failed nodes so that the distribution of nodes is maintained. All clusters sync with the new primary nodes. Now let's say you have set up the cluster with cluster mode enabled configuration and have replicas. Now you want to test the availability and fault tolerance of your application. You can do this by calling test failover API using console, ElastiCache API, or AWS CLI. You can test automatic failover on up to 5 shards in any rolling 24-hour period. If you call this operation on shards in different clusters, also called as replication groups, you can make the calls concurrently. If you call this operation multiple times on different shards in the same replication group, the first node replacement must complete before a subsequent call can be made. To determine whether the node replacement is complete, you can check events in the Amazon ElastiCache console or use AWS CLI or ElastiCache API. Here's what you will see in the ElastiCache events. For replication groups and cache clusters, you will see the message test failover API called for node group followed by the node group ID. Second message for replication group and cache cluster will be failover for master node followed by the primary node ID to replica node followed by replica node ID completed. For cache clusters, there are two additional messages. Recovering cache nodes followed by node ID, and finally, finished recovery for cache nodes followed by the node ID. The amount of data your application needs to process is seldom static. It increases and decreases as your business grows or experiences normal fluctuations in demand. If you self-manage your cache, you need to provision sufficient hardware for your demand peaks, which can be expensive. By using Amazon ElastiCache, you can scale to meet current demand, paying only for what you use. ElastiCache enables you to scale your cache to match demand. With Amazon ElastiCache for Redis, you can start small and easily scale your Redis data as your application grows, all the way up to a cluster with 170.6 terabytes of in-memory data. It allows you to scale your Redis cluster environment up to 250 nodes or 250 shards, depending on your cluster configuration. It supports online cluster resizing to scale out, scale in, scale up, and scale down your Redis clusters without downtime and adapts to changing demand. To scale read capacity, ElastiCache allows you to add up to 5 read replicas across multiple availability zones. To scale write capacity, ElastiCache supports Redis cluster, which enables you to partition your write traffic across multiple primaries, also called as sharding. Now let's discuss two Redis shard configuration examples that utilize this 250 node limit. In the first example, we'll have 125 shards, which will be made of one primary and one replica, which is equivalent to 250 nodes. Now let's take the largest memory node size, which ElastiCache offers, which is R524 extra large. It has 635.61 gigabit of memory. In this case, the cluster memory will be 635.61 gigabits into 125 primaries, which is almost equal to 80 terabits or 88 terabytes. In second example, let's take 250 shards made of one primary and 0 replicas, which is also equivalent to now 250 nodes. Okay, now let's take the examples. In the first example, let's take 125 shards made of one primary plus one replica, which is equivalent to 250 nodes. Let's take the largest supported memory node size in ElastiCache, which is R524 extra large, which holds 635.61 gigabit memory. So in this case, the cluster memory 635.61 gigabit times 125 primaries is equal to 80 terabyte or also equivalent to 88 terabytes. In the second example, let's take 250 shards made of one primary and 0 replicas, which is equivalent to 250 nodes. Now with the same R524 extra large, which holds 635.61 gigabit, the cluster memory will be 635.61 into 250, which is equivalent to 120 terabyte of data. Now, if latency or throughput issues are plaguing your cluster, you might need to scale out to resolve the issues. Your cluster can face one or more of these issues: memory pressure, CPU, or network bottleneck. Horizontal scaling allows you to change the number of node groups, shards in the replication groups, by adding or removing node groups or shards. The online resharding process allows scaling in, scaling out, while the cluster continues serving incoming requests. You can use the AWS CLI command as shown here to add the required number of shards. In this example, it's adding 2 shards totaling to 5 shards in the Redis replication group. Or you can use ElastiCache Redis console to add shards. Regardless of the mechanism you choose, ElastiCache will add the shards and rebalance the slots on your behalf. Scaling in also works similarly, with removing the shards and rebalancing slots automatically on your behalf. Because scaling is a compute intensive operation, there is some degradation in performance. Nevertheless, your cluster continues to serve requests throughout the scaling operation. How much degradation you experience depends on your normal CPU utilization and your data. At the beginning of talk, I mentioned that Amazon ElastiCache for Redis is a fully managed service. Let's review it in some detail. With ElastiCache, you no longer need to perform management tasks such as hardware provisioning, software patching, setup, configuration, monitoring, failure recovery, and backups. ElastiCache continuously monitors your clusters to keep your Redis or MEMCACHED up and running so that you can focus on higher value application development. It provides detailed monitoring metrics associated with your nodes, enabling you to diagnose and react to issues quickly. In addition to this, on Redis Engine, ElastiCache adds automatic write throttling, intelligent swap memory management, and failover enhancements to improve upon the availability and manageability. Now, managing Redis cluster on your own can be hard. We heard this feedback from customers that it was difficult to self-manage Redis. Their dev team had to invest a good amount of time in managing hardware provisioning, software patching and updates, setup, configuration, and backups. We were being told consistently that it takes too much time managing the full stack because of Redis outage impacting their application performance. Therefore, it was hard for them to make Redis highly available. Further, compliance management is especially hard. Maintaining security, patching vulnerabilities, and configuring encryption all require security expertise. Online scaling can be error prone, and replication performance needed to be consistently monitored. In addition, scaling Redis seamlessly is difficult because building the tools and automation to manage clusters and staffing 24/7 reliability engineers is just very expensive. We listened to our customers who wanted to move out of self-managing Redis and start using ElastiCache. As a result, we have launched online migration support to enable them easily move their Redis workloads to ElastiCache. With this feature, you can now easily move your data from self-hosted Redis on Amazon EC2 to fully managed Amazon ElastiCache for Redis in cluster mode disabled configuration. Once you provide ElastiCache the endpoint and port of your Redis cluster, ElastiCache will replicate the data from your cluster in real time. Once the data sync is complete, you can update your client applications to start using the newly populated ElastiCache cluster. It is that simple. Let's talk about prerequisites to this migration. There are only 4 requirements. First requirement, identify the target ElastiCache cluster. The online migration feature supports Redis 505 clusters in cluster mode disabled configuration that has multi-AZ enabled and does not have encryption and Redis auth enabled. Second requirement, verify compatible configurations between your Redis on EC2 and ElastiCache clusters. Your Redis version can be from 2.8.21 onwards, and ElastiCache will migrate your data directly to Redis 5.0.5, which is the latest supported version in ElastiCache as of today. Redis config protected mode should be set to no. If you have bind configuration in your Redis config, then update it to allow requests from ElastiCache nodes. Number of databases between the source and target clusters should be the same. This value is set using databases in the Redis config. If you have renamed commands, ensure that your Redis commands that perform data modification are not renamed. This is to allow data replication to ElastiCache cluster to succeed. Let's see how the migration works. Migrating your data from Redis running on Amazon EC2 to Amazon ElastiCache requires an existing or newly created Amazon ElastiCache cluster that meets migration eligible configuration and is also in line with your desired configuration, including attributes like node type and number of replicas. Ensure that EC2's IPs is private. We recommend that you assign or create ElastiCache cluster in the same VPC as your Redis instance. If the VPCs are different, then set up VPC peering to allow access between the two clusters. For more information on VPC peering, you can refer to our public documentation on access patterns for accessing an ElastiCache cluster in an Amazon VPC. The security group attached to your Redis instance should allow inbound traffic from ElastiCache nodes. The migration begins when you call the Start Migration API or CLI command. The migration process makes the master node of Amazon ElastiCache cluster as a replica to your source Redis cluster. Using Redis replication, data syncs between your Redis cluster and Amazon ElastiCache. Once the data is in sync and you're ready to cut over to Amazon ElastiCache, make changes on your application side so you can call ElastiCache cluster post migration. Once the client side changes are made and you are ready to cut over, call the Stop Migration API. This API will promote Amazon ElastiCache to an independent cluster with master and replica. Now you can redirect your client application to start writing data to Amazon ElastiCache cluster. Throughout the migration, you can verify the status of replication by executing Redis CLI info command on your Redis instance and on Amazon ElastiCache primary node. As I mentioned that it is cluster mode disabled using Redis Engine version 505 or higher. So ElastiCache cluster does not have encryption in transit or at rest. It has multi-AZ with auto failover enabled, and it has sufficient memory available to fit the data from your Redis instance. These are the configurations that you have to ensure that your ElastiCache configuration, cluster configuration is met. To configure the right reserved memory settings, please see our public documentation on managing reserved memory. Now, the migration process takes in two parameters, your Redis cluster CNAME or IP address and the default port values populated. If you have a configured different port for your Redis instance, you can add that value here. Once you click on Start Migration, all data in ElastiCache cluster will be deleted and will be populated with the data from your Redis instance. The migration process takes in two parameters, like I said, your Redis cluster CNAME or IP address, and the default port value is populated. If you have configured a different port for your Redis instance, you can add that value here. Once you click on Start Migration, all the data in ElastiCache cluster will be deleted and will be populated with data from your Redis instance. In case your selected ElastiCache cluster does not meet the migration configuration requirements, you will see this message. Follow the requirements to provision a compatible ElastiCache cluster before you can retry the migration. Once the migration has started, verify that Redis master link health status on your console or master_link_status in the info command on ElastiCache primary node. You should also verify the replication status using Redis info command before cutting over to ElastiCache. Once you're ready to cut over to ElastiCache, you can call Complete Migration API or click on Stop Data Migration from the console. This will cut off the link between Now, stopping the migration. This will cut off the link between your Redis cluster and ELC, promote the ELC cluster to be independent with the primaries and replica, and you can continue to monitor writes to your cluster and ElastiCache. And when everything looks good, redirect your application to only write to ElastiCache. To confirm the promotion to primary, check for the event complete migration successful for test cluster. ElastiCache cluster status will change from migrating to available. In case you want to force stop the migration, regardless of whether the data sync has completed or not, you can check force migration stop parameter on the console. We do not, with this parameter enabled, we do not verify whether the data is in sync or the connectivity is live. Otherwise, we will check and won't apply the operation and continue to do the migration. You can restart the migration on an ongoing migration by selecting the same cluster and clicking Migrate Data from Endpoint. This process will give you the warning about an ongoing migration in the cluster and ask you whether you want to still proceed with the new migration process. You can decide to move forward or abandon at this time. Okay, now let's go through the demo and see how the online migration feature works. All right, so here we see there are three terminals. The first terminal on the left, I will use this to connect to Amazon ElastiCache. The terminal on the top right is connecting to Amazon EC2, which is running a Redis instance. As we can see, the Redis version running on Amazon EC2 is 4.0.1, as you can see it in the top right window. In the bottom right window, Again, I have used Amazon EC2, but then I have used that to test the connectivity to my Amazon ElastiCache cluster. And you can see when I ran info server, I am able to get the information. The Redis version is 5.0.5, which is great. So the Redis versions are compatible with each other, and I'm also able to test the connection. Now let's check the memory on each of those. So in here, we can see that the used memory is 4.27 megabytes, and the peak memory is 1.54 megabytes, and the total system memory is 15.38 gigabytes. In the ElastiCache side, the used memory is 5.18 megabytes, and the max memory is 9.8 gigabytes, which is great. So there is enough memory available on both sides to allow the operation to happen. Now, since the prerequisites are met, now we can go ahead and start the migration process. So as you can see on my left terminal, I have written the CLI command, which is AWS ElastiCache start migration. I've given the replication group ID, which is ElastiCache online migration. The region, I'm running this in US East 1. The customer node endpoint, which is an IP address, and my login credentials. Now let's check in Amazon ElastiCache for events to see whether the migration has actually started or not. So I call the command AWS ElastiCache describe events, and I can see that I see the message starting migration operation for replication group ElastiCache online migration, which is great. So now the online migration feature will enable ElastiCache cluster to become the slave of your Redis cluster, which is hosted on Amazon EC2, and will start syncing data from that. And we can check the replication lag on both Redis hosted on EC2 as well as Amazon ElastiCache to see whether how far the sync is and how long will it take to complete. Oh yeah. So here I can see on Amazon EC2 side, when I do info replication, the role is master and it has connected one slave. And the master replication offset is 1218. Now, when I see the replication information on Amazon ElastiCache, I see the role has changed to slave, and the master host is now my Amazon EC2 IP address, and also the slave replication offset is 1232. Okay, so now let's check how the migration is going. So I run info replication on both EC2 as well as Amazon ElastiCache using the right-hand side terminals. On the top right, I can see the master, the role of master is correct. The role of master, the role is master. Okay, let's check. Now let's check how the migration is proceeding. I do the info replication command on both right-hand side terminals. On the top right, I can see the role of Redis hosted on Amazon EC2 is master. It has connected one slave, and the offset is 1316. Now let's verify this information from ElastiCache cluster. On the bottom right, you see the master host is the IP address of Amazon EC2. The role of this node is slave, and the offset of this slave is 1316, which means that they both are now in sync. Now I'm ready to cut over. So in order to cut over, all I have to do is call the complete migration command from my terminal. Okay, so when I test Amazon, wait, let me restart. So let's check the events to see what's going on. So when I type the command ElastiCache describe events, I can see the last message is complete migration has started for replication group ElastiCache online migration. So which means that my command went through and ElastiCache is doing all the cleanup, disconnecting the nodes, and making ElastiCache cluster independent and promoting it to primary. So let's wait a few more seconds, and then we'll call this command again. All right, now let's try again and see whether our migration completed or not. As you can see, the last message that we see when I call ElastiCache describe events command, the message is complete migration successful for our replication group ElastiCache Online Migration. That's great. So our migration is successful and completed. On the right-hand side, just for verification, you can see I did info replication on Amazon EC2 Redis cluster, and on the bottom right, I did the same command on ElastiCache cluster. So you can see on the top right, the role of the connected slaves is now 0, which means the Redis cluster has been disconnected from ElastiCache. On the what? You said ElastiCache. Okay. On the right hand side, okay, so we'll do this again. So on the top right, as you can see, the info replication command returns the role as master, which is great, but the connected slaves is 0, which means that Amazon ElastiCache cluster has disconnected from this Redis cluster hosted on EC2. On the bottom right, we see the results of info replication on ElastiCache cluster. It shows the role has now changed to master for that node. Connected slaves are 2, which is great. So our cluster is now an independent cluster with 1 master and 2 slaves or 2 replicas. So this concludes the demo. And now, how do we go from there? If you need more information, we have documented all the steps required to do the online migration to ElastiCache. As you can see, we have listed how to prepare your clusters for migration, initiating migration, how to verify the migration process, completing the migration process, and how to use this feature using console. So this concludes this talk. So I would be happy to take any questions if you have, and enjoy. Thanks for cut it over there. So this concludes our talk, and I'll be happy to take any questions that you have, and hope you enjoy your rest of the day. Thank you.